In this video, we will see dry run of the code. Now let's do a quick dry run of this problem, right? So I will call this function is subtree with the root and subroot. Okay. So let name it. Okay, that is 3 and 4. So let me call this is subtree. Let me call as sub. Okay, and I will call with 3 and 4. So in the recursion stack also 3 and 4. Okay. Now once I call this function, I will check is my subroot is null. No, it's not. Is my root is null? No, it's not. So let me mention this root and subroot. Now I will check is identical, like is root and subroots are identical. So basically I will pass 3 and 4 in this function, right? And I'm not going into deeper of it because we have already solved it. So basically this will call one more function is identical, right? So let me propose I with 3 comma 4. Okay, so you will call I with 3 comma 4, right? Once you call this function, right, here you will simply return p dot value is not equals to q dot value. So this function will return false, right? So this function will return false, right? And here we will get a false value. Once we are getting a false, right, I will again one call this function. So can I say first of all the work done, the work of this function, identical function is done because they called it, it returned false. So yes, the work is done. I will simply remove it. Once this is removed, right, I will call the same function subtree with the left value. So that means I will call with this 4 node, right? Okay, and this 4, right? I'll call this function. Okay, what is this function? Again, is my subroot is null? No, let me put it here as well that I am calling this function. Is my subroot is null? No, it's not null. Subroot is not null. Root is also not null. I will come here and I will pass to is identical function. So I will call this identical function with a 4 value and a 4, right? With a 4 value and 4, right? So basically it will, this function, right, 4 1 2, it will return me true, right? So this function, and this function is called, it will return true, right? I'm not solving this identical function because that we have already solved in the last question, right? So this identical will return true, right? Because these are identical, right? 4 1 2, it's identical, right? So it will return true, right? So can I say my this function is done, right? Basically they called it, it returned true. Okay, once this is done, right, okay, it, once this condition is true, okay, it will return true, right? So who called this function basically is identical, right? This subroot, so it will return to true, it, this function also, and it will return to 3 comma 4, right? It will return to this function also. So here you can see, right, identical 4 function is true. So basically I will simply remove from this stack, and work of this subtree is subtree 4, that is also done, right? So I will remove this one also, right? Once I will remove this one, right, I have the true value here, right? And let me remove this as well. Then I will call the next function, right, subtree with root dot right, right? So I will call the subtree the root dot right, and what is this? That is 5 comma 4, right? Now if I call this function subroot is null, no. Is root is null, no. I will call the is identical function again. So I will call the is identical function again with 5 comma 4, right? So first of all, let's call the subtree 5 comma 4, then identical function 5 comma 4, and this 5 comma 4 will return false, right? This function will return false. So now can I say the work of this function is also done, right? So yes, this is done. We'll simply remove it. Now once is it is returning false, right, what I will do, I will again call this function, right? Because if it is false, it will check for other root dot left, right? So it will check for other root dot left. First of all, is the work is done, so I will remove this one also, right? I will again one call one function right here. So basically I'll call for null, right? So I will call for null because null is in the left. I'll call for null. Is your subroot is null? No. Is your root is null? Yes. So simply return false. So I will return false. And can I say, like here I have called null with 4 value. Can I say my this null with 4 value, that is also done, right? With 4 subroot, that is done, and it is returning false. So here we have a false, right? and that is also removed from here. Now once this is done, I will call the subroot with the root dot right. What is in the root dot right? That is again null, right? So I will call this one function with null comma 4, right? Okay, and if here in this cell, if root is null, it will return false, so it will return false. That is also done, right? So I can simply mention here, and it is returning false, so the work is also done here, right? So here you are getting false from both the side, right? Here itself you are getting false, here itself you are getting false, right? And that's the main thing, right? The main answer will be false or false, basically false. So you will return false here as well, right? So can I say null comma 4 is also done, 5 comma 4 is also done, right? Because false from here and false from here, so it will return false. Now from here we are getting true. In one condition we are getting true, right? About the last function called 3 comma 4, and from 1 we are getting false, and we have an OR condition, right? So if any one of the true, it will be true, so we are getting true, and that's why we will return true. Okay, and that's why the answer will be true here, right? And that's the last of this function, right? It will also remove from the stack, it will also remove from the stack. Okay, now suppose in the same question, right? Suppose in the same question you are mentioning something, suppose one node like 0, right? So what will happen? Nothing will too much change, right? The only thing is, like suppose you have called this function, let me put the red color. Basically you have called the subtree with 3 comma 4, right? So basically here it will also, it will get false, and here it is getting false only, right? So the answer will be false, right? So this is how it will work. Basically exactly same as our is identical. Basically in subtree what you are doing, you are just checking is the root, this root is equal. Okay, like here you are checking is root and subroot are equal. No, these are not identical. You are moving to root dot left. Okay, if they are equal, so that's okay. Okay, you are getting an answer. If they are not equal, then you are checking for root dot right and with an OR condition, right? So let's talk about the time and space complexity. So here the time complexity is a bit different, right? You are calling two functions, right? One is subtree, and one is identical. Okay. Now imagine a case where you have all the values are equal and all we have different trees, right? Suppose you can take this example, right? One, or you have one here, okay, and you are checking this one, right? So here in each case, right, or there are different test cases also. Here in this case, you will call the identical function again and again, right? Right, you will call the identical function again and again, and suppose this is also exactly same, right? Suppose that is also a bit near same, right? Or let me extend this one, right? So here you will call this, right? You will first call this identical function, then subtree. Even if you reach here, you will call this function again and again, right? So basically, right, you will visit each node, right, in the worst case, that is n, right? Your total nodes in a tree, and you will visit here also in identical, also you are visiting each nodes, right? And for each node you will visit, right? So n into, suppose for your subroot there are m nodes, right? So for each n node you are visiting m nodes, so the time complexity will be n cross m. Okay, and suppose both are equal, root n is nearly equals to m, so the time complexity will be big O of n square. So the time complexity here will be big O of n square. Now let's talk about the space complexity. Okay, so space complexity in general, it was of height of the tree, right? So again here it will be an high recursion stack will be an height. Okay, suppose let's h1 is the height of your tree, and for each h1 function, right, suppose you reach to the last leaf node, right, you will call identical function, that is also a recursion stack, right? So height h1 and h2, right? So that will also nearly equals to suppose 1 h, right? Same height. Now what I'm saying, See, in one of the cases, if there is a skewed tree, what is skewed tree? Basically, a tree that is aligned either in left or right. So suppose a tree is like this. Okay, we have 1, 2, 3, 4. Okay, and suppose 3, 1, 2, 3. So here the height is also equal to the number of nodes, right? 4 are the number of nodes and 4 are the height, basically height of this node. So here h1 plus h2 will becomes n plus m, right? So in this is the case, then the space complexity will be n plus m. Otherwise the space complexity will be h1 plus h2. Okay, so taking the worst case scenario, okay, where these nodes can be equals to the height, right? So the overall time and space complexity I am writing here will be big O of n square if both are equal, and space complexity will be big O of n, right? So this will be the time and space complexity of this approach, and this is how you can simply understand this problem. A very good question of subtree of another tree. Okay, yeah, that's all for this problem. Okay, see you in the next problem.